Welcome! In this video, we'll show you how to use Anthropic's Claude model to generate precisely controlled specific format outputs for your AI applications and workflows. We'll focus on portable concepts that work with any cloud platform, making it flexible for your needs. That said, to give you a practical example, we'll build a demo application and show how to use the structured output from Claude as a structured input to data stores like Google Cloud's BigQuery. Users will interact with our service directly, avoiding the need for us to discuss advanced networking concepts, and we'll focus on a simple API backend and trust you to develop the front-end code if needed. The concepts and code we'll cover will work similarly whether you're using Google Cloud Platform, GCP, Amazon Web Services, AWS, or any other cloud service. For real production systems, you would typically want to provision your systems using infrastructure as code, so consider using a tool like Terraform to set up your services and data storage. We'll use Python to create our service because it's easy to understand, but you can use any programming language you prefer. For this demonstration, I'll use the Cloud Shell editor in Google Cloud, but you can use any development environment you like. Before we continue, it's important to note that using Claude's API is not free. However, the costs are usually very small, typically just a few cents, unless you're operating at a large scale. When working with AI interfaces like this, you should be careful about too many user requests, such as during a denial of service attack, as this could increase costs significantly. While Anthropic has some protective measures, it's wise to add your own controls like rate limiting or user authentication to keep costs under control. Let's begin working with our code, which we'll make available in the video description. We'll create a main Python file, and to keep things simple, we'll use Google Cloud Functions instead of creating a full Docker setup. This allows us to run simple Python code on Google Cloud Run without needing to build Docker images ourselves. This approach helps keep our function concise and straightforward. For our function, we'll need several important tools. First, we'll use the Functions framework, which is Google Cloud's utility library that reduces boilerplate HTTP code. For Python functions, this library uses Flask behind the scenes. We'll also need to work with JSON data. We'll import the OS library to handle environment variables, the Anthropic library for AI functionality, and the JSON library for data processing. This gives us a solid foundation for our project. We'll need to list these requirements in a file called requirements.txt. This file should specify the functions framework and include a recent version of the Anthropic Python SDK. Even if you're using a programming language that doesn't have an Anthropic Claude SDK, you can still make direct API calls. The SDK just makes our work easier by handling authentication and preparing the HTTP requests to the API. We'll start by setting up a client, which requires an API key from Anthropic. We'll store this key as an environment variable for security. Then we'll create our function with an HTTP decorator, which tells our Cloud function that it can receive HTTP requests. While we won't add security features to this API demonstration, in a real application you might want to add security measures and usage tracking depending on your needs. For now, we'll focus on the core technical concepts, which you can later adapt for your specific use case. The function will receive JSON data in the request, and if it can't get that data, it will return an error code. Now we come to the exciting part, making the Claude API call. This will use the client we set up earlier to create a message. At the time of this tutorial, Claude 3.5 Sonnet is the best available model, so we'll use that, but you could try other models as the concepts and usage remain similar. We'll set up a maximum of 4,096 tokens and configure the temperature setting to control the AI's creativity level. In our example, we'll work with a practical scenario, automatically processing user emails to extract order information. This serves as an interesting example of how we can use Claude's capabilities. The important part is setting up the Claude tools. We'll create a tool called Order Extractor with a detailed description. The input schema is a bit counterintuitive at first. While we're actually trying to get output that matches our schema, Anthropic wants us to think of this as an input to our tool, as if we're feeding data into BigQuery. We'll create an object with three main properties: customer for the customer's information, product for what they're ordering, and quantity for how much they want. These types follow the JSON schema standard. For required fields, we'll specify that only the customer field is mandatory. This is strategic. Even if the product and quantity details are unclear in the email, we can at least capture the customer's information and fill in other details later. We'll need to clearly specify this tool choice in our configuration, forcing Claude to use the tool every time. After setting up the API call, we'll eventually need to load the information into BigQuery, But let's take it one step at a time. First, we'll just return the results to make sure everything is working correctly. We'll test this thoroughly on Google Cloud Run. While we could build off of Terraform code to get the resources that we need, for this demonstration, we'll create these resources manually in the Google Cloud Console. For our setup, we need to configure a Cloud function using the Python runtime. We'll use an HTTP trigger to make it function as an API endpoint. Importantly, we need to make this a public API by setting the All Users permission. We'll also need to set up some BigQuery components, specifically a dataset and a table for storing our orders. Let's go to the Google Cloud Console and navigate to Cloud Functions. If you're using AWS, this would be equivalent to AWS Lambda. Since this is a new project, we'll need to enable some APIs first. We'll allow unauthenticated invocations since this is a demo. Because we're not doing heavy processing, we can use minimal memory and CPU settings. Though if you're generating lots of text, you might want to increase these. We'll set a 3-minute timeout just to be safe. Next, we need to set up a service account, which we'll call Order Extractor. We'll grant it BigQuery Data Editor permissions right away. Once we've created this account, we'll select it for our function. We'll also need an Anthropic API key. Let's walk through setting this up. First, we'll visit Anthropic's website and click Try Claude, signing in with a Google account. From there, we'll navigate to the API console. It's important to note that you'll need to set up valid billing and ensure you have funds available before you can create an API key. Once your billing is set up, you can go to the API keys section and create a new key. We'll copy this key into our Cloud Functions environment variables. Looking at our other settings, we'll check that the building configuration and connections are correct. Then we'll select our Python environment, we'll use the latest version, and copy our code from the editor into the function. One important detail, we specified create record as our entry point, so make sure that matches in the configuration. We also need to copy over our requirements file so the function has access to all the libraries it needs. To test our extraction function, we'll need to make a curl call to the URL. Let's try this together. We'll set up an HTTP header to indicate we're sending JSON data, paste into our Cloud function endpoint, and provide some test data. Let's try ordering a few pizzas. Our first attempt results in a 500 error, indicating something's wrong. Checking the logs, we see there's an issue with getting the JSON data. It turns out we made a simple mistake. We need to use getJSON instead. After updating our code and redeploying, we'll try again. The results are interesting, but not quite right. The AI has made some assumptions it shouldn't have. It created a fake last name, invented a product that wasn't mentioned, and missed the quantity completely. This shows we're missing important information in our implementation. Let's improve this through better prompt engineering. Let's try another attempt with our order extractor. One parameter we can adjust is the temperature setting, which controls how creative or focused the AI's responses are. Let's see if changing this helps our results. After making some adjustments, something still isn't quite right with our responses. To diagnose the problem, let's print out our prompt to see exactly what we're sending to our Cloud function. Looking at the logs, we spot the issue. We're not properly interpolating our string in the prompt. There's a small but important bug in our code. We forgot to add an F before the string to enable string interpolation. Adding this simple prefix will allow us to properly insert our order information into the prompt. This should quickly fix our results. And indeed, after this fix, things work much better. Now, when we test it, we get accurate results. For example, 2 cheese pizzas ordered by John Smith. Let's try some more complex examples to really test the system. The results are now exactly what we want to see. With that small bug fixed, our extraction system is working smoothly. As a final step, let's send this data to BigQuery. While this isn't the main focus of our video, it's useful to see how we can use our nicely structured data. We'll need to add the Google BigQuery library to our requirements file. Version 2.7.0 or higher should work well. We'll add the important statement at the top of our file, include a date-time field for our records, and create a BigQuery client. But before we can test our updated code, we need to create the dataset and table in BigQuery. And don't forget, when we update our function, we also need to update the requirements file to include the BigQuery integration. On our first try, we get an error. Checking the logs, we see we simply forgot to add the new environment variables needed for BigQuery access. After adding these variables, we get a proper JSON response, a good sign. Looking at our new table preview, we can see everything working together: the timestamp, the email content, and the 3 extracted details for each order. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all the code and diagram files in the description as well. Thank you very much for watching to the end, and please enjoy responsibly.